Welcome back to another lecture on Java. We are still looking at OOP, and today we're going to look at part 2 of OOP. So these are the contents of the lecture today. We will go through each one of them one by one. So object class. So in Java language, object class is a super class of all classes in Java. You can say it's a parent, it's the same thing. So that means even if your class does not explicitly specify that it extends from object, implicitly it actually extends from that class. And this object class has around 11 methods, and some of them can be overridden. Most common ones to redefine are the equals, the hashCode, the toString, and the finalize. The finalize one has been, since Java JDK 9, it has been marked as deprecated, which implies that in future versions of Java it will be removed completely. Let's just look at that class quickly. We come here. So this is the class, object class. We are even told that class object is a root of the class hierarchy. Every class has object as a superclass. All objects, including arrays, implement the methods of this class. So we see that it has even native methods here, hashCode, equals, clone, toString, this notify all. This has to do with threads, wait. Then finally we have the finalize, which I mentioned that it has been marked deprecated since JDK 9. And the object first is a class. So I remember when I started coding, I used to confuse these two a lot. So an object, think of it as an instance of a class. It's like the realization of a class, because a class is just a template, or you can think of it as a blueprint for creating an object. So when the runtime creates an object, it needs a template on how to create that object. So a class is that template, and a class contains properties and methods, as you can see on the diagram below, that cycle class. Object. What is an object? As we mentioned, an object is an instance of a class, and an object resides in the heap memory. And the way to access that object in memory is via a reference. So when you say scanner input equals to new scanner, input is a reference. So there is no way for you to know about this new scanner object in memory except through the reference to know where it resides. As I mentioned in one of the previous lectures, we mentioned that think of this like a road sign. It will tell you this is the way. If you want to get to Liberty Mall, if you want to get to Mall of Africa, if you want to get to, any kind of place you want to, the road sign will show you. And the same goes for string s equals to hello. This hello, although you don't have new here, an object is created, it's saved into the constant pool for you, and s, it's just a reference to that object. Then you have interfaces. So an An interface is an abstract type used to specify the behavior of a class. It is also known as pure abstraction. However, since the arrival of Java 8, interfaces have evolved so much that we can almost say that the pure abstraction which they were known for is normal, because now you have default methods, you have static methods, JDK9 added private methods, all those things. Almost it's like they are removing the abstraction away from an interface. Because in the olden days we only knew interfaces to only contain abstract methods. That's what we knew an interface for. But today you can have method implementations, default, static methods, private methods, and all that. So declared methods in an interface are abstract by default. Without any body, they are abstract. And if you have any variable in an interface, it is by default public, static, and final. It's a constant. It will not change. So this means that you cannot explicitly say private, static, final. It will not work. Abstract classes. An abstract class is a class that is declared abstract. It is also known as partial abstraction. It may or may not include abstract methods. This class cannot be instantiated, and it can be subclassed. And there are two ways when you are subclassing it. When you subclass an abstract class by a concrete class, that concrete subclass must provide the implementation for all abstract methods from the parent abstract class. However, if you subclass the abstract class with another abstract class, the subclass is not required to provide implementation for the abstract methods. Interface versus abstract class. So when to use the two, how can you differentiate between them? So an interface, you use it when you are not sure about the implementation details. You just have you don't know anything about what implementation should look like, but you do have an idea of what could be there. So you use an interface. But when you have partial knowledge of the implementation or little knowledge, you use abstract classes. Another difference is that interfaces can be implemented by classes. So a class can implement an interface, but a class cannot implement an abstract class. It must extend that abstract class. However, when interfaces are working amongst themselves, an interface can extend another interface. An interface will not implement another interface, because implement means you're giving us the implementation. It will not work. You can try it in code, you will notice that it will not work. Then we have what we call object equality versus object identity. Identity determines whether two objects share the same memory address. That is, are they pointing to the same object in the heap? Equality determines if two objects have the same state. So if two objects are identical, that is, they share the same memory address, then those objects are equal. But just because two objects are equal does not mean they share the same memory. address. We will look at that. So object identity. We see that the identity of an object distinguishes one object from another. It is useful to think of an object's identity as a place where its value is stored in memory. So S here, string S equals to Java, S1 equals to Java. We are checking object identity. Object identity checks whether these two objects are pointing to the same memory location. So, something I wanted to demonstrate. If we are here, we already have this employee object. We have this 2. Okay, for now we can just delete. So guess what happens if I say x equals to y by the clone method? You see that this is false, and the reason for this to be false is because the clone method will give a copy of that object. It will give you the same copy. But if I just say y is also pointing to what x is pointing to, I will get true, because now they are pointing to the same object. And it goes without saying that they are equals. Method should also give us true, but that should also give us true when we run it, as we can see. But that should always be the case if you have overridden your equals method correctly. But that only will apply for objects that are not pointing to the same object in the heap. But because these ones, they are pointing to the same object, they will always be equal, even if you did not override the equals method, because it's one object. So let's go back to the clone. We already established that this is false. Okay, let's establish with the equals. It should also give us false. Supposing that we have got here 100, we also have got here, and we have 100. So these two should be equal, which is object equality, because the state is the same. So if we run this, we must get equal, but we still get false. And the reason is because we did not override our equals method correctly in this class. So if we come here, we can decide to override equals method. So what we do is we can let me just say override equals. Okay. Okay, it's fine. Let me just use this. Okay, equals. This is fine. So let's just run this. Now we get true, because we have overridden the equals method correctly, and we compared the names, the age, if they are the same. This gives us true. But if we do reference equality as we saw, this will give us false, because although they are equal, they are not pointing to they are not same objects in the heap in memory. This now explains the statement we saw here. If two objects are identical, then they are also equal. But just because two objects are equal does not mean they share the same memory address. That is what we just explained now. But for strings, we already dealt with this scenario in our previous lecture, where we explained the issue of constant pooling of strings, why these are equal. These are equal and they are also identical. Okay, we have already explained with our custom objects. This is fine. Okay, then we have equals and hashCode. Equal objects must have equal hashCode. There is a contract. That's a contract between equals and a hashCode method. Then we are also told to always override hashCode when you override equals method. Failure to do this will cause problems when working with hash-based collections, like hash maps, hash tables, and all those. It is not required that if two objects are unequal according to the equals method, then calling the hashCode method on each of the objects must produce distinct integer results. So what this means is that if two objects are not equal, it's possible they can have the same hashCode, even if they are not equal. But if they are equal, they must have the same hashCode. Then comes the issue of hashCode collisions, where you find that, especially when you're dealing with hash maps, that two objects that are completely different, they have the same hashCode, which actually puts them in the same bucket. Then there is a way we will deal with that when we are dealing with collection, to see how the hash map implementation deals with collisions. Then object versus reference. You should never confuse a reference with the object they refer to. Object resides in the heap and does not have a name. It's not possible to access the object except through a reference. A reference holds the object's memory address. It is the object that gets garbage collected, not its reference. That's what you have to understand between these two. As you can see here, that demo D1 equals to new demo. D1 is this object that is in memory. It's pointing to it, but itself it's not that object. Here D1 is a reference variable, which refers to object of demo class. Then there is this versus super. So you use this when you are referring to the current object. Super used to refer to the superclass. So let's see how these are used in practice. So let's say, as you can see here, what we are doing, you want to check, is the object passed here equals to this object? Is it equals to this object? Return true. So this is the current object. So you are trying to check, are you comparing the object with itself? That's the meaning of the statement. If that's the case, return true because it's the same object. So let's check. We notice that when we were having x, this scenario, x dot equals y, when we run this, it gave us true, but we did not specify the equality. We did not specify how this object should be equal. Like we did not override the equals method. So what we need to do, since we are using the equals method in an object class, let's see how that method is implemented. Equals. So you see that the default implementation will check if you are comparing the object with itself. If that's the case, then return true, which is basically what's happening here, because object y is the same object as x, so it's you comparing the object. So we are relying on the method, the equals method in the object superclass to do the comparison for us. That is what I wanted to clarify. So now let's come to the use of this and super. You can just close this. So you use this when you want to refer to the property of the current object. And this is another perfect example. If you remove this keyword here, you are actually reassigning this to itself, the parameter. But to differentiate, to tell the runtime or Java that you are referring to the property of the class, you use this to do that. If maybe you wanted to refer to a property of a superclass, which maybe could be protected, you will have to say super. But we don't have a name in a superclass. So what we could do here, we could say HR. So HR is an employer, it's an employee. So what we need to do here then is to, I'm just going to make this protected, just this one for the sake of the demonstration. So you can decide here that you want to have so let's say you want to say have this set name here. So when you say this, because this name is protected, it's available, hence it works. But you can also say super in this case, because now you are telling it refer to the superclass variable, which is the same as if you say this, it will still work. It will still work for you. But assuming you also had a private string name. So now having this and super in this case is different. This one will refer to the name that is in the superclass, but this will refer to the name that is in the subclass. That's the difference that you have to make. Now, also when it comes to the use of this and super, you cannot use this and super in a static context. Say you have a static method here. You can just say public static void test. So I can just take this to a subclass. Okay, let me just leave it here. So, and then you have another maybe test2. We cannot now say super dot test, because this super and this, they are only available in the context of instances. But the minute you add static keyword, you are no longer concerned about instance or object. You are just concerned about a class. That is why static methods are called class methods, not object method. So that means this test2 method does not require an object to be realized. But with super, you are dealing with an instance, you are dealing with objects. So the minute you say this, you are saying, you are talking object language or object terms. You must be in a context of an instance. But static keyword takes you out of that context. So you cannot even say this dot, because you are in a context. You are not in an instant context. That's why you cannot use them. Also important to highlight is that when you have let's say a constructor and you want to call a super constructor, you are allowed to just call super constructor like this. And this super must be the first in this construct. If you had other statement, this will be a problem. The same goes to this keyword. This must be the first, but now this you are actually calling a constructor. So let me just create another constructor that is maybe int I. So if you say I, this will work. You're calling this constructor. You can not also have another statement before it, but you are allowed to have the statement after it. Also, super and this for constructor, when you're calling a constructor a super constructor, or when you're calling a constructor in the same class, they cannot be used together. So you cannot say super. This is not allowed. You cannot even put it below the other one. So as you can see, this super here is actually calling the super constructor of employee, although we don't have it. So if we have employee and then we say string name, our subclass will not work, because now the parameterized constructor has overridden the default constructor. Therefore, you need to provide a string here for it to work. Okay. Yeah, so this is an error, because now since you have a super class, you must, what the compiler is doing this for you, but it does not find a no argument constructor in the super class. So the only way to have that solved is to do this. Or if you want to solve this problem, you have to say this. So you are calling this constructor, so that means this one is calling this constructor, and this constructor is calling the super constructor. So you must be aware of those things when you're dealing with constructors and subclasses and superclasses. Then object lifecycle. We mentioned that inside a constructor, it is a way to intercept the creation of an object in Java. constructor has the same name as the class and does not have the return type. As we saw with account with employee class, where we actually said, but this will be an error because now we have added a constructor. When you do this, you're actually intercepting the creation of this object, setting the state before the creation. Then we have the finalize method. We say we are intercepting before, then we have the finalize method. Since we are talking about object lifecycle, this is the method that gets called before an object is garbage collected. But as we mentioned, the finalize method has been marked as deprecated since Java 9. So as you can see, you are not even allowed to do this. Override method that is deprecated must be remover. This is not what we are allowed to do. The object, the code still works, but the IDE is just warning you that you are not supposed to do this. Then when you are passing arguments to method, we have what we call pass by value and pass by reference. Java uses pass by value, not by reference. The pass by reference, if you code it in C++, that's where you have such kind of flexibility. You can actually pass by reference, even the primitives. Java will create a copy of a reference and pass it to the method. But that reference that it has created a copy of is pointing to the same memory reference in the heap, the same memory in the heap. Object immutability. We already talked about object immutability a bit in one of our previous lectures. So an object is considered immutable if its state cannot change after it's constructed. So after it has been created, its state cannot change. The question that now lies is, how do you create an immutable object? First, we saw with the string class that you declare it final. All the fields are private. You do not have setter methods for variables. No setters should be defined. And then all fields declared final, so that their values cannot be assigned, can be assigned only once. That means you are preventing reassignment. Then initialize all those fields via a constructor. And then have getter methods. And those getter methods must return a copy rather than an actual object reference. And for that, you can use cloning. You clone an object. And then there are several ways. There is a way to do what we call object cloning. How do you achieve object cloning? And your class must implement clonable interface. And then you will then override the clone method. That clone method, as you override it, now you provide the implementation of it. So let's just do this quickly. Let's go back to our object. We see that we have the clone method here. It creates and returns a copy of this object. The precise meaning of copy may depend on the class of the object. The general intent is that for any object, blah, the expression, okay, let's not read that. But you realize that this clone method is marked as native, which means it's written in another language. Maybe C++ or we don't know, in the implementation of the JVM. Native to the platform. It's not written in Java. That's the meaning. So now, if we come here and we say we want to clone our object, as we saw here, we say x.clone. In our employee class, we have this clone method, but observe what happens here. We are saying super.clone. So in other words, what we are essentially doing here, we are calling the method in object class. And there is no implementation of it. Implementation of it is found in the native platform at runtime. That's where now the native way, or the way it has been implemented by the implementation of the JVM, they create a copy of the object and they give you the data. So what we have done here, we have done what we call swallow copying of the object. Let me go back to the slide and continue. So we have what we call swallow copying and we have what we call deep copying. So swallow copying simply makes a copy of the reference to A into B, or as you saw in our employee, to E into E2, or to X into Y. Think about it as the copy of A's address. So the addresses of A and B will be the same. They will be pointing to the same memory location, data contents. And then now we are saying okay, let's just say X. So this is false because a new object was created for you by the runtime, and then the copies, the content of that data for things that are called, that we say they are immutable, like the string, like the wrappers and all that, they still remain the same. So I will explain this further. Let's not do not allow the slide to confuse you in a way. This might not make sense. We are saying that when you do swallow copying, as you can see with the way I created this method. Okay, let me just remove this clone method for now. I'm just gonna come here and create a clone method. See, I didn't create it. It says to do. That means the cloning is not perfectly complete. That is what we mean by the shallow copy that we created. It says copy mutable state here. So the clone can't change the internals of the original. This is what we are trying to explain here with the shallow, but I guess we didn't explain it like properly. So we will see. I'm going to give a perfect demonstration of what we mean. So what we mean essentially here is that we are referring to the state here. That when we do shallow copying, the state of that particular object for immutable objects is the same. They are pointing to the same thing, even for mutable objects. But the issue is that with a mutable object, when you do shallow copying like this, you're having a problem. We are going to see that problem. This is shallow copying, and you don't provide any implementation. For mutable object, this is what the slide is trying to explain here. For mutable objects, you are having an issue. They are pointing to the same memory address. That means that if you do a change in the copy, in the clone, it will unintentionally affect the original cloned object for that particular implementation you will have done, because in that clone we didn't do anything for mutable objects. Then deep copying simply makes a copy of all the members of A, allocates memory in different location for B, and then assigns the copy members to B to achieve a deep copy. In this way, even if A becomes no longer non-extensial, B is still valid in memory. That means if one of them gets removed, it does not remove the other one. The correct term to use would be cloning, where you know that they both are totally the same but different. Store as two different entities in the memory space. You can also provide your clone wrapper, where you can decide via inclusion and exclusion list which properties to select during deep copy, which is what this method is actually trying to explain to do in the to-do here. So you see that the deep copy, we have different reference objects that were created, new objects. So I'm just going to explain this for us so that we see what we are trying to explain, so that you don't get confused with the definitions that we have here. Let's go to shallow copying. So we see that shallow copying, a shallow copy of an object copies the main object but does not copy the inner objects. They are still the same. So if the inner properties, some of them are mutable and some are mutable, you're going to have a problem. So we say when you have a custom object employee and it has primitives, wrappers, and string types only, then you can use shallow copying or shallow cloning, as you may want to call it. That wouldn't affect. Let's demonstrate that. So in this case, we have employee containing name, integer, age. So if you can see what we have here, we are saying object employee X equals to new employee. Then we set name and we set age. So what I want us to do is, let's set this to be love and let's set this to be 90. So remember what we said, that if you only have strings, wrappers, and primitives, this will not have any effect. So what I want us to do now is to do this. We are going to have these placeholders. So what I want us to do, we want to say x.getName. And then we are going to have y.getName. Then we can duplicate this line and have getAge and have getAge as well here. observe that you're going to get different values. See, we have God, we have love, we have 100, we have 90. One would have thought that since we are changing the same thing for the object, the God change, but that is not the case. But now when you are dealing with mutable state now, or mutable objects, let's just add another property here. Let's call it address, and we can create getters and setters for it. We have created that. So what I want us to do is we are going to create address, new address, and we say address.set street. This street we can say Johannesburg. This is fine. And what we want to do, we want to say x.set address, and then we leave it like this, and then we duplicate this line also. Then we say get address get street, get address get street. We want to run this code. So far we have Johannesburg. Observe what happens if I say y get address dot set street, and then now I set it to let's say I set it to Durban. Observe that I'm only getting address for y, and I'm setting it to Durban, not for x. See that it has overridden for x, but these objects are two different objects, but it was able to override the one for x. So now this means that our clone method is not correct, so we have to correct our clone method so that when we do cloning, we do not unintentionally affect our own mutable state of an object. So we come here. So what do we do when we get into the clone method? So it's obvious we have to create another object here, address. New. Or maybe we can even clone this one. Let's try that. Then after we have cloned this one, we say address1 dot set street equals to address dot get street name. Then we say clone dot set address dot address1. We got the clone. Okay, because we cloned, this is still not working. So what we need to do, we have to say new address, sorry. And then set this, and then the clone set address, give it a new address with this value, then run the code. Then we do not have side effects of unintentionally overriding the other properties of other objects. That is what we are trying to explain with deep copying. We saw that shallow copying, when you only have the wrappers, the string, the primitives, just returning super.clone is even enough. You don't even need to we can come here. You don't even need to do all these things. So you can basically return this here. Okay. Alright, it's fine. It's still the same thing anyway, because you say super clone, you typecasted it to what you are looking for, then that's fine. Then just returning that works for us. We saw that. And we saw why we needed to do the deep copying. We saw the problem with shallow copying. We saw the problem with shallow copying, that when you have mutable state, it will be affected by the change in the clone. And we saw deep copying. We saw how you can prevent unintentional side effects.